So here we are going to talk about numbers and how they relate to sort of doing chemical calculations and such. So dozen is a word that means the number 12. Mole is a number that means 6.02 times 10 to the 23rd. Now, why would we use such a ridiculously large number? Well, it turns out that in chemistry, when we're actually talking about actual chemical reactions, it's important sometimes to refer to actual number of atoms or molecules in my system. But atoms and molecules are so incredibly small that if we actually wanted to talk about how many, for example, water molecules are in my beaker of water, the number would be very, very large. So we don't like dealing with really big numbers. And so we've come up with essentially a word to represent a very large number. And that word is the word mole. Sometimes the E is actually sort of dropped off. The abbreviation for mole is just MOL. So when we're converting from moles of atoms to numbers of atoms, we just need to know this 6.02 times 10 to the 23rd. It's just a number that is represented by a word. And that number is what is known as Avogadro's number, given the symbol N sub A. You don't need to memorize that 6.02 times 10 to the 23rd if you're doing any sort of calculation. I'll give it to you, but you need to recognize it and recognize the concept. Now, when this allows us to now further go and figure out what's on that periodic table. In the periodic table, in each square on the periodic table, we have three different things. We have the chemical symbol, we have the atomic number, which is the number of protons, and then there's that non-integer number, the number that's got numbers behind a decimal place. That number actually represents two different things. It represents the average atomic mass in what are known as atomic mass units. But more importantly for us, it also represents the mass of 1 mole of that element in unit of grams. So for example, we look on some periodic tables, will say that the number underneath the chlorine is 35.453. Now, that means that if I have 1 mole of chlorine atoms, it would weigh 35.453 grams. This allows me to convert between actual number of chlorine atoms and mass of chlorine. So this will allow me to, for example, go into the lab, measure the mass of a certain sample of an element, and be able to convert it into, oh, this is how many actual atoms I have of that particular species, which is going to be important to us in doing stoichiometric calculations later on. Now, remember that 35.453 is an average mass. So let's figure out let's take a moment to explain a little bit more what that means. So there are two different flavors of chlorine in the world. First flavor of chlorine is chlorine 35 isotope, and 75.53% of all the chlorine in the world, as far as whenever we measure it, this is the ratio, this is almost 3-to-1 ratio, is a chlorine 35 isotope, and its exact mass is 34.969 atomic mass units. And then the other 25% is a chlorine 37 isotope, which its mass is very close to 37, as you would expect. So for calculating that number that's on the periodic table, that weighted average, what we do is we take the fractional amount of each isotope and multiply it by its exact mass. So our 0.7553 is the fractional amount of chlorine 35. We multiply it by the exact mass, get a certain portion. Then we take the fractional amount of chlorine 37, multiply it by its exact mass, gives us our other fractional portion. We add that all together, and we get our 35.465. Now you'll notice it's a little bit different than what the periodic table says, and that just has to do with the fact that I'm only using 4 significant figures over here, and our mass is actually off in the 4th significant figure. So just sort of small rounding error. I'm just trying to, the emphasis here is not to get the right answer, the emphasis here is to show you how that number comes about. But what's key to remember is that no atom of chlorine actually weighs exactly 35.465 atomic mass units. That is an average of all the chlorine atoms in my bucket, and that's that weighted average.